All right, so for this video, I'm going to go through and answer just some of the questions on this review. And if you need any help for any of the other ones, you can always reach out through email. All right, so the question I'm going to do first is this $800 converting from decimals. All right, so what we do is we have first look at our decimal where we have negative 12.1008. Let me just make this a little bit thicker. And when we're going to do this as our answer, I can do this a couple of different ways. The first way I would suggest that you do this, this should be minus 12 actually, and negative, since the question was negative to begin with. But the first thing that you should be doing is, I would say, write negative 12 as our whole number, and then we're going to just write in our fraction. So all I'm going to focus on then are these decimals, 0.1008. That's all that I'm going to focus on. Right? So when we do this, remember, we have to know all of our place values. So we have our tenths, our hundreds, our thousands, and our 10,000s. So that means that this fraction, or this decimal, 0.1008, can be rewritten as 1,008 over 10,000. And then from here, we just have to reduce. Now, you might not know which numbers go into these, so I'm just going to break it down for you nice and slow. If you know a larger number that goes into it, then by all means, divide by the larger number. When I see that this number ends in an even, I know that they're both at least divisible by 2. So I'm just going to go ahead and start breaking this down by 2 just to make this a little bit easier for me. So 1,008 divided by 2 is going to give me 504. And 10,000 divided by 2 is then 5,000. All right, then from here, I'm going to reduce this again, and I'm going to reduce it again by 2. I'm just going to show you that you can always just keep going by the smallest number. It might just take you a little bit longer, but you'll still at least get the right answer. So I'm just going to keep dividing by 2 until there's something that jumps out that might be a little bit more like, oh yeah, I definitely know that this goes into this. 4 I know does go into this as well, but we're just going to keep going it by 2s. So 504 divided by 2 is going to give me 252. And then 5,000 divided by 2 is 2,500. Once again, these both end in 2s. So I'm just going to keep on dividing by 2 until I can't anymore, or until there's another number that I think might jump out clearly to all of us. So 252 divided by 2 is going to give me 126 over top of. This will give me 1250. And then once again, I see, okay, they're still both divisible by 2 because they're both even. So I'm just going to keep on dividing by 2. Well, this is then going to give me 63 over top of 625. Then from here, this is it. There's no other number that divides evenly into this. 63 is not even anymore. 625 ends in a 5. So we know that that's divisible by 5, but 63 isn't. If we add up our three numbers, so 6 plus 2 is 8, plus 5 is 13. Since 13 is not divisible by 2 or by 3, I know that 625 is not divisible by 3. And if you want it, you can go ahead and start writing out all of the different factors to see if they do. But this is our final answer for this. So there'll be negative 12 and 63 over 625. So even if you're not strong with simplifying, you can always just keep doing it by the smallest number possible, which is, in this case, 2 every single time. All right, the next one I'm going to go over is a $600 question on converting fractions. And when we're converting fractions, we have 8 and 1/16, and we're converting it to a decimal. Same thing as we did before. Since I see I have my whole number 8, I know that my answer is going to be 8 point something. So I can just focus then on this fraction of 1 over 16. And when we do that, we know that this is the same as 1 divided by 16. So we can go ahead and do 1 divided by 16 to convert this into a decimal. Remember, the number in our denominator is what we're dividing by. A lot of you, when we're doing this in class, we're mixing this up and doing 16 divided by 1. And I think you're doing that because 16 was a larger number. But in this case, we're getting a decimal. So since we're getting a decimal, we know that the smaller number would have to be what we're dividing into. Right? So when we're doing this, we say, okay, can 16 go into 1? No, it can't. So I'm going to put a 0 there. So remember, there are infinitely many zeros after this 1. So I'm going to put another 0. Now I'm asking myself, when I put the decimal here, I need to put the decimal there as well because it's in the same place value. Can 16 go into 10? No, that still can't. So we're going to go ahead and put a 0. Then we're going to go ahead and add another 0. So now we're looking, can 16 go into 100? And yes, it can. 16 goes into 100 6 times. And if you're not sure, you can multiply 16 by different numbers off to the side. You can write 16 out and add them up to see how many times it takes for you to get to 100. But it's going to be 16 goes into it 6 times. And then we multiply. 6 times 10 gives me 60. 6 times 6 gives me 36. So 16 times 6 is 96, and we subtract down. 100 minus 96 is going to give me 4. Then 16 can't go into 4, so I need to add another 0, and I'm going to bring that down. And how many times does 16 go into 40? Well, it goes into it 2 whole times. 16 times 2 gives me 32. So I'm going to subtract here, and this then gives me 8. Once again, 16 can't go into 8, so I'm going to go ahead and add another 0 and bring it down. And 16 goes into 80 5 times. And 16 times 5 is 80. So then when we subtract here, we have a remainder of 0. So this tells me that this is my decimal, 0.0625. I'm not going to worry about the 0 that was out front because I'm already replacing that with this 8 because we knew that we had a whole number of 8 to begin with. So it's 8.0625. And that would be our final answer. All right, now the next question I'm going to go through is the $400 question on adding, subtracting fractions. So we have negative 3 over 8 plus 17 over 24. So remember, when we're adding, subtracting fractions, we need to have common denominators. So when I look at these, I say, okay, well, 8 goes into 24, so I don't need to worry about changing this fraction here since it's already set up to the denominator I want to. So I need to ask myself, 8 times what gives me 24? Well, 8 times 3 does. So I need to multiply both the numerator and the denominator by that 3. So now it gives me negative 9 over 24. And since I didn't need to multiply this, it just remains 17 over 24. Once we get our denominators the same, we can go ahead and add or subtract what's in our numerator. So I'm going to rewrite this as negative 9 plus 17 over top of 24. Remember, I'm always going to show you this step. You don't have to necessarily show me this. I can rewrite negative 9 plus 17 as 17 minus 9, which is a problem that you all should be able to do. And 17 minus 9 is going to be equal to 8. So this will then reduce to 8 over 24. All right, but now remember, or this will not reduce, this will simplify to 8 over 24. And now we have to reduce our fractions. We can't leave them not simplified. So we will then say, okay, well, what number divides evenly to 8 and to 24? And hopefully 8 jumps out at both of you, to all of you. So 8 divided by 8 is 1, and 24 divided by 8 is 3, and that will give you your final answer of 1/3. All right, now the next question we're going to do is a $600 question from the add or subtract as well. So it's negative 5 over 12 minus 7 over 9. Now in this case, 9 doesn't divide evenly into 12 like it did in the other problem. So now we have to figure out, okay, what is a common denominator we can have? And I know a lot of you just multiply these two denominators together so you get 108, which is fine. But that means you're most likely going to have to simplify, not most likely, but there's a good chance that you'll have to simplify at the end, and you might be giving yourself more work. So what I would suggest you do is you take your smallest number, or you can take both of them, but you take your smallest number, and I would just write out my multiples. And as I'm writing out my multiples, so 9, 18, 27, 36, 45, 54, as I'm writing them out, I'm actually thinking, does the other number go into any of these? And 12 doesn't go into 9, 18, 27, but it does go into 36. So that tells me that that is my least common multiple or my least common denominator. And if this doesn't make sense to you of like knowing which one 12 goes into, then take your other denominator and write out its multiples as well. And then you can see, all right, well, do they share any? And yes, they both share this 36. So I know that my least common multiple or my least common denominator would be 36. So my goal now is to turn both of these into 36. So what do I need to multiply 12 by to get to 36? If you write out your multiples, you can just count 1, 2, 3. So I can write 3 over 3 because we know this is equal to 1. And 1 times any number it's itself, so we're not changing its value. 3 times negative 5 is negative 15. And then 9, it's 1, 2, 3, 4. Or you just know that 9 times 4 gives me 36. So then we'll multiply by 4 over 4. 7 times 4 is 28. Right now, I'm going to go ahead and write these under one fraction. So when we're adding our fractions, we never add our denominators. So then it becomes negative 15 minus 28. Well, when they're both the same sign, we can just go ahead and add them. So 28 plus 15, which is then going to give me 43. And since they were both negative, the answer is actually negative 43. And then I look and see, okay, well, are there any numbers that divide evenly into 36? And since 43 is a prime number, there are no numbers that multiply into both 43 and 36, so that would then be your final answer. All right, now this next one. This is the last one I'm going through with the fractions as well. So negative 7 over 10 minus. Actually, I'm going to go over the $1,000 one as well. Minus negative 5 over 12. So the first thing you should do before you do anything with this is minus a negative, rewrite it as what you should know, that it's actually plus. Right? So it's negative 7 over 10 plus 5 over 12. Right, so then from here, I'm going to go ahead and look at my denominators and say, all right, are there any common denominators? What is the least common denominator that they share the least common multiple? So I'm going to write it out, 10, 20, 30, 40, 50, and 60. And then for 12, we have 12, 24, 36, 48, and 60. So I see that they both share 60. So now my goal is to rewrite these under the fraction, or with the denominator 60. So now I'm going to multiply this. Well, 6 times 10 gives me 60, so I need to multiply it by 6, so negative 42 over 60. And 12 times 5 gives me 60, so this will then give me 25. So now when I go to combine these under one fraction, it's negative 42 plus 25 over 60. So remember, when we have different signs, we make them both positive because we are used to, so this way we can use the method that we know. We take the smaller number and we subtract it from the larger, so 42 minus 25. So now we can use our borrowing method and all the methods that we are used to solving. And then after we get this answer, we look back and say, okay, the larger number, was that negative or positive? And since it was negative, this is actually a negative 17 and not positive. So then this is going to give me negative 17 over 60. Once again, 17 is prime, so there's no numbers that divide evenly into it, so that will be your final answer. All right, so this one here, we have 3/10 plus 1/2 minus 9 over 4 and plus 3 over 5. So what I do when I'm doing problems like this is I take the smallest number, or you can write them all out. But I'll write them all out. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And I'm going to go ahead and write out my 4s. So 4, 8, 12, 16, 20, 24, 28. And if you run out of space, you can always write more than what you need as well. 5, 10, 15, 20, 25, 30, 35. And then the last one will be our 10. So 10, 20, 30, 40, 50, and so on. So when I look and say, okay, is there any number that they all share? And yes, they all share this 20. So I'm going to go ahead and know that all of these need to be rewritten over top of 20. So plus 20, minus 20, and plus 20. So I know that these are all going to be rewritten with the denominator of 20. So 10 times what gives me 20? So 2. So I'm going to multiply both of these by 2. 3 times 2 gives me 6. 1 times 10, or 2 times 10 gives me 20. So both of these need to be multiplied by 10. 4 times 5 will give me 20. So both of these will be multiplied by 5. And 5 times 4 gives me 20, so both of these will be multiplied by 4. All right, then from here, I'm going to rewrite this all under one fraction, or on one fraction, just to show you that we're only adding the numbers up top. And now I'm going to rearrange these. I'm going to add all of my positive numbers first, just to get rid of the multiple positives. So I'm going to add these together. 6 plus 10 gives me 16, plus 12 gives me 28. So now I'm left with 28 minus 45 over top of 20. And then from here, since I know that I have different signs, I'm going to just go ahead and look at them as both positive. I'm going to take the smaller number and subtract it from the larger one, which is then going to give me 17. And since the larger number was negative, that means my answer is actually negative 17. So it's negative 17 over 20, which cannot reduce, and that is your final answer. All right, I'm going to go over the question 400, 600, and 1,000 on this one. So for 400, the thing when you're doing decimals, you need to just make sure that you are lining them up properly. So when I do this one, I'm going to do 154.12. So since my larger number is already being subtracted by my smaller, I don't need to worry about changing or manipulating anything. And then it's going to be minus. So 89 needs to be written under our tens and our ones. And then our tenths and our hundredths need to match up as well. So I can write it like this. So a lot of you will want to move this all the way over to the right and have them lined up on the right. But you only do that when you're multiplying. When you are adding, subtracting, you need to have your place values lined up properly. So then from here, I'm going to add a 0 here, because we know there's infinitely many zeros after any of our last decimal. And then we're subtracting. So in order for me to do 0 minus 1, I need to borrow from here. So I'm borrowing 10. So 10 minus 1 gives me 9. I can't do 1 minus 8, so I'm going to borrow as well. So then it gives me 11. So 11 minus 8 is 3. 0 minus 0 is 0. So now my decimal point. Can't do 4 minus 9, so I'm going to go ahead and borrow. So 14 minus 9 is going to give me 5. I'm going to borrow from this 1, so 14 minus 8 is 6. Our positive number was the bigger number to begin with, so it's 65.039 is your answer. All right, so for this next one, the $600 question, we have negative 25.7189 minus 14.093. So remember, when our signs are the same, we can just go ahead and add them. So I'm just going to go ahead and line these up so I can add these nice and easily. So 25.7189, and underneath it'll be 14.093. So remember, we need to make sure that we're lining them up correctly. So I'm going to add a 0 here just so it's just a little bit easier for me to see that there is a 0. So 9 plus 0 is 9. 8 plus 3 is 11, carry to 1. 1 plus 9 plus 1 is going to be 11, carry to 1. This gives me 8. So now I'm going to put my decimal because now I'm getting to my decimal. 5 plus 4 is 9, and 2 plus 1 is 3. But remember, both of these numbers were negative to begin with, so that means our final answer is going to be negative. So it'll be negative 39.8119. Remember, when we're multiplying two negatives, that does turn positive, but when we're adding or subtracting, that doesn't just automatically make things positive. It depends on which numbers are larger. And since we're starting on the left side of our number line to begin with, at negative 25.179, when we're moving further to the left, we're getting even further left, so it's going to still be a negative number. Right? So just make sure that you're not thinking about your multiplication rules with our adding subtracting. All right, so for this last problem here, a $1,000 question, what I'm going to do first is I see I have two negatives, so I'm going to go ahead and get rid of those negatives. You could do this any way that you want, really, but I'm going to get rid of my two negatives first because I know that I'm just adding them, and maybe that's a little bit easier for me. So I'm going to go ahead and just write these out. I'm going to add them together, so 12.587 plus 14.194. I'm going to add these together. This gives me 11, 17, so it gives me 18. This gives me 7. This gives me 6 and 26. And since they're both negative, I know my answer is going to be negative 26.781. And then I'm going to go ahead and add that 21.7095. All right, so I'm going to go ahead and just add them first. You could do this any way that you want. You could have combined these first and then got that answer and combined it with the negative 14 after. It's really your call. But once I do this, I see I had different signs. I'm going to treat them as both as positive, remember. And then I'm going to look and say, okay, I'm going to take the smaller one and subtract it from the larger one. So it's going to be 26.781 minus 21.7095. And remember, make sure that you're lining them up. So I'm going to go ahead and put a 0 here as my placeholder. I can't do 0 minus 5, so I'll borrow from the 1. So 10 minus 5 gives me 5. I'll borrow from the 8. That gives me 10 now, so this gives me 1. 7 minus 0 is 7. 7 minus 7 is 0. 6 minus 1 is 5. And 2 minus 2 is 0. I don't need to write that. But since my larger number was negative to begin with, that means that my final answer must be negative 5.0715. All right, I don't ever go over the final Jeopardy question. That is something that is meant to be like an extra credit type question. So it's meant to see if you guys can apply this and extend it on your own. It's not anything that would be worth any points on a test. So I don't go over it because I want to see what you guys are capable of doing and extending from what we have learned. So taking knowledge that we've learned and applying it in a different way. All right, but that is it for this video.